Hey, welcome back to ZK MasterTech. Today we are working on an 8310R that has a fuel dosing code. Go figure. Thank you, EPA. Anywho, it has a code for the fuel dosing pressure. The inlet pressure is extremely low. The customer is trying to side dress with this machine, so we need to get this tractor up and running today. I apologize for not having any content last week, but I've been really busy, mainly doing a bunch of stuff you guys have already seen me do before, you know, combine inspections. But I do have a lot of combine work that we need to do. Today we're going to try to get this tractor running, and then, you know, I think later on we'll probably do some more videos on some combine repairs. So I'll bring you guys along for that, but let's see what's going on with this tractor and see if we can't get it running for this guy today. Let's check it out. Okay, I got Josh up in the cab this morning. Doing a little training out in the field today. Got him connected to the machine. What do we got going on?
Well, we have derate conditions and fuel dosing issues.
Okay. So which fuel dosing code do we got?
We've got pressure extremely low. We've got actual pressure mismatch. Signal's low.
Okay. So more than likely, we don't have fuel dosing pressure.
Yeah. So
we need to go in and actually engage the pump and see what kind of pressure we got going on in this thing. All right, I've got updates. So we had codes for the fuel dosing inlet pressure extremely low, fuel dosing pressure mismatch. So the ECU's desired pressure wasn't matching the actual input pressure. So, but we went to that code, and then there's other codes that might take priority over those codes, and we had a code for the fuel pump circuit resistance low. So we go into that diagnostic, and then we performed a terminal test, which show that connector. So we got these probes that have a certain part number that Deere tells you use that are the exact terminal. And so we can stick it in this connector and feel, if I can get that in there, and feel if it has a slight drag to it. So that terminal's fitting really good. So all the terminals tested good. So the next step is we hook up this diagnostic test box, and of course the diagnostics will have you turn this S1 dial to a certain position. You put your multimeter into here, and then basically we're checking for supply, unswitched battery voltage. So we had 12.2 volts there, and then also I was monitoring that data in Service Advisor, and it was 12.2. Diagnostics say to replace fuel pump. So we took this pump housing off, which if you guys seen me doing the 946ER before, I did a video on it. It's basically the same thing. So we took that pump housing off, we swapped out this electric fuel pump, and we're going to see what happens to that pressure, because before we started the electrical diagnostics, we went into Service Advisor and did an interactive test where we could turn that pump on and monitor the pressure. And she was about 100 PSI. So it says that the pressure is supposed to be greater than 116. So our pressure is a little low. So we're going to put a new pump on there today, and we're going to do a fuel dosing air purge test, which is going to purge all the air out of the system, and then we're going to see what kind of pressure we're running after that. Alright, so you see me guys use that diagnostic test box. Yes, it is a special John Deere tool, and I'm using it because in the diagnostics for this particular code, it's wanting us to use that test box and putting that box to, you know, certain settings and seeing what the voltage is. I'm not going to get into, you know, how that box works and everything. I'm trying to train a technician on how to do it the Deere way. But, you know, could we take that connector off and use a multimeter and check power and ground? Absolutely. Could we load test those wires, you know, putting a headlamp in series with the power wire to make sure that the wire can hold a load? Absolutely. You know, can we do resistance checks from the ECU to that connector at the fuel dosing pump to make sure we don't have any resistance issues in those wires? Absolutely. You know, we could take a schematic and use a multimeter and we can diagnose all those circuits old school. But you know, in this situation, I'm going to use the diagnostic steps that Deere gives me, and we're going to run it through the steps, and we're going to we got the fuel pump replaced. So right now Josh is in the cab, he's connected to the model again, and we're going to turn that pump on and see what kind of pressure we have. Yes, we probably got a little air in the circuit, but we're just seeing, you know, kind of where it's at the moment. And then we're going to do a fuel dosing air purge test and see what it does after we purge all the air out of the system. And of course the exhaust filter is moderately plugged, so I know once we get the system working properly where we can dose the correct pressure of fuel, we'll be able to do a regen and complete it successfully, and then hopefully our filter's not plugged, and then this customer can take this tractor to the field today and do some side dressing. So let's see what happens now. Okay, so I got a little updates here. We went through and we turned this pump on, and we had about 98 to 100 psi when we kicked the pump on. And I went into the theory of operation, and I just read on how this system works, so I didn't give you guys any false information. I know that the diagnostics said that, you know, it asked me if the pressure is greater than 116, but it wasn't. You know, if I go in and I read the theory of operation, you know, this is a variable speed pump. So we're getting an unswitched, in order for this pump to work, we got to have unswitched battery voltage, you know, which we checked, which was 12.2 volts. So we checked the power and ground on the connector, and then we have to have an enable signal from the ECU, which is basically, you know, like just telling the pump to turn on. And then we have two wires that we communicate to the ECU on a CAN bus. So the ECU is controlling the speed of this pump based on command. So the pressure is going to change. Your fuel dosing pressure has to change with the exhaust pressure. So it's taking the difference in exhaust pressure and calculating how much fuel dosing pressure we need in order to regen properly. So when we go into this pump and we just turn it wide open, you know, it hits, I think it jumps up to like 116 and then kind of goes down to 100 psi, and that's because in this fuel pump housing, it regulates the pressure. You know, it's not going to let it go above 116 psi basically, right? So what we decided to do was go ahead and run a fuel dosing air purge test, and what that does is kind of like a mini regeneration. So we're monitoring, you know, this is our exhaust stack where we have our DOC and our DPF. So we've got temp probes. We've got 3 probes in here. We got one at the bottom. We're checking the temperature of the DOC inlet, so that's the exhaust coming into the inlet. We check the temperature between the DOC and the DPF, so that's our DOC outlet. And then we've got our DPF, which is our, you know, exhaust filter, and we're checking the temperature on the outlet of the DPF. So the ECU is looking for that temperature in the DOC and the DPF to kind of increase and then stabilize, you know, and once it gets to a certain temperature, and I think it's somewhere around like 600 degrees or so, and it will start dosing fuel into the exhaust. So we're pumping pressure from our pump, we're getting it from the fuel filters, we're bringing it through the pump, we're pushing it through this housing where it's regulating the pressure, and we're coming down here to our control valve, our dosing unit here. And so we've got a shut-off valve and we've got a control valve, which kind of looks like a fuel injector like you'd see on a gasoline engine on a car. It's just kind of built into that valve there. And then we're monitoring the pressure coming in and out of this valve here. So then we bring pressure from this valve, and it comes back around to this fuel dosing injector, which is kind of hard to see in here, but there you go. So that's our fuel dosing injector right there. So that is a mechanical injector, And when the pressure gets above 38 psi, it's going to unseat the needle valve and spring in there, and then it's going to start, dosing that fuel into the exhaust. And I think it runs a frequency of 1,000 hertz, I believe. And then it's going to start dosing fuel, all right? So while we're doing the air purge test, we can go in and we can monitor the fuel dosing inlet and outlet pressure. We can look at the DOC and the DPF temperatures and make sure that, when we're dosing fuel and we see pressure coming in and we see pressure going out, is our temperature in the exhaust coming up? Yes, it was. So once we got the air purge test done and it said it was good, so then we went and did a service regeneration because we had a code for the exhaust filter being moderately restricted. Okay, so we're going to do a service regeneration now that we have a new pump in there, and we're going to monitor the data while it's regenning, and we're going to look at the same things we were looking at during the fuel dosing air purge test. So we're looking for the fuel dosing system to turn on. What's its state? Is it idling? Is it active? When it's active, are we dosing pressure to our control valve, and then we're dosing fuel into the exhaust? And then we know that because our temperatures are coming up, right? So when fuel goes into that catalyst, it's heating up, and it's putting that heat and that high temperature into that DPF to try to burn the soot into ash. Right, so we did the regeneration, monitored the data, and then we're looking at the soot level once it completed the regeneration, and I think it took about 30 minutes or so. And once it was completed, of course, the engine idles back down to 1200. During the regeneration, the engine goes to 1800 RPM, and when it's done, it drops to 1200, and then we're going to look at that soot level, and when we're good to go, that soot level is going to say not needed. So we got it to not needed, and it's working properly. So with the codes that were in the machine, I think we have just an intermittent problem with, the electronics in this pump going bad. So I think we're just having an intermittent trouble, because they said, on and off for the last 3 years on this machine, they said they were just having troubles with it doing an active regeneration, and they were constantly having to do park regens on this machine. So hopefully this will fix the issue. Of course, it did the regeneration just fine and didn't set any codes. So we're going to go ahead and let this customer take this to the field and side dress today, and then I'll just keep in contact with him to make sure that the tractor is functioning properly, and we'll go from there. Hopefully she behaves herself, Josh. All right, now that we got that tractor done, we pulled this 8370R in this guy's shop here, and we're going to inspect the tractor. But first thing, whenever I fired it up, I immediately heard the fan drive banging and clanging, so that's awesome. So we just went ahead and pulled the shields off and looked into the fan drive, and this thing's going to need a new fan drive. So it was also setting a code for the fan speed high. But it's had a new style dry driven on it that's fairly new, so that's good. So started looking into the fan drive itself, and the bushings are completely wore, and it's loose on the splines, and you could see as soon as we cracked the little boot here, it started leaking oil and a mixture of grease, and a little bit of water came out. So here we got the inner shev on the ground here. You can just see how wet everything is. These bushings in here are smoked. So it's loose enough to where that's binding on the shaft and it can't go back. Whenever the oil gets released from those pistons, it's supposed to return back. Excuse me, it's supposed to return back, but I think it's getting bound up on that shaft. So it's causing the fan speed to be high because the ECU is demanding it to go slower, but it can't physically move, so that belt just stays where it's at and runs too fast. So this boot here, you can see it's got a big tear in it, so that's where our water's coming from. The pistons are leaking, that's where the oil's coming from, and of course the bushings being all loose and the seal and the grease seals are bad, so that causes the grease to sling out. Plus you have a sealed bearing in here, and it's got its grease slung out past the seal too. So just a combination of things, but when I see one of these greasable drives that's just in this worse of a shape, then we just go ahead and we're going to replace it with the new dry style driver, because I'm having problems getting parts to actually rebuild these anymore. So we're going to go ahead and get one ordered. Should have it in soon, but for now we're going to have to just temporarily put this back together until we come back so the customer can drive this thing in and out of the shop. And we're going to go ahead and inspect this rig. So we're going to look everything over real good, check for leaks, make sure everything works, kind of look at the engine hours and see, you know, where the engine hours are at and what things that need serviced at certain hours, and, you know, of course we'll be marking that all down. Then we're going to be coming back here and we're going to be checking the hydraulics, the SCVs. We're going to see if the couplers can hold pressure. We're going to flow test it, and I'm going to show you guys how we do all that, so stay tuned. Okay, so we reached sweat level 7, got the bandana out here, but if you guys want to know a little bit more how to do a tractor inspection, you can check out my video I did with Molino Farmer. We inspected his tractor. It was a track tractor, but you know, it's got a lot of similarities here, but we're not going to go like deep dive in the inspection. But one thing I wasn't able to cover in my videos is, you know, doing all the pressure checks on the hydraulics. So that's what we're going to get into now. Right now we've got I got a little 10-foot hose to a 3,000 or 5,000 psi gauge here. We're going to check to see if the couplers can hold pressure. So I've got this hooked into the extend port here on the #1 SCV, and we're going to pressure check it. So Josh will pull the lever back. This is going to raise pressure up to about 3,000 psi. The pressure will stabilize, and when he goes to neutral on the SCV lever, it shouldn't drop to 0. If that pressure bleeds off real quick, that lets me know that that coupler is not holding pressure. And then we're just going to do each one and see which couplers are good or bad. So fire it up. One back. You can see we got 3,000 pounds on the gauge, one neutral. See how that bled right off? Go back, hold it again. Let go. See, that coupler's bad. It's leaking. Watch that. It should hold pressure. So now we're going to move to the other side and see what that does. Forward. That bleeds off immediately. Off the SCV lever, see how that's holding the pressure? That's a good coupler right there. Take my pressure off. It's holding pressure, that one's good too. Back. Holding. It's holding. both couplers on 1. We got the extend on 3, and then both couplers on 4 that need replaced because they're not holding pressure. So, awesome. Anyway, we'll go ahead and we're going to hook the flow rater up to the back of the tractor here, and we're going to flow test each SCV and make sure that our pump is flowing the amount of oil for spec. So we're going to be looking somewhere around 28 gallon per minute at 1,000 RPM, and I think it was 43 gallon a minute for 1,500 RPM, I believe. So I'm going to get the flow rater hooked up here and see what kind of flow she's got. All right, now we're going to check pump flow. We got a flow rater hooked up. I got the gauge hooked up to the pump outlet DR underneath the tractor over by the main hydraulic pump. There's a DR that we're snapped into, and we're going to put a load on the system with this flow rater, and we're going to increase the pressure to 2,500 psi on our gauge here, and then we're going to read the flow on the flow meter. So Josh, if you want to start it up and go to 1,000 RPM. PSI. Well, I'm just going to let that run for a little bit because we need the oil hot. We need it, you know, somewhere between 100 and 150 degrees before we're going to make an accurate pressure. So here's rating how many gallons per minute we're running. Supposed to be at 28 gallons per minute, and now we're in between 32 and 35. Still doing good on flow. Our temperature's at 120 degrees. Go ahead and go to 1,500 RPM. So there you go. You guys know how we do the main pump flow test, and you could see where we were way within spec. You know, I think I seen 43, 44, you know, at 1,500 RPM there with the pump at 2,500 PSI, and that's checking that pump pressure on the main pump DR down on the main hydraulic pump, and then we're checking the flow with the flow meter. So with that pressure and that flow, we are well within the specs for this tractor. Besides the, you know, the couplers not holding pressure, and we'll get that fixed, and then she should be all good from there. All right, so we got that inspection wrapped up. If you guys want to see, you know, an in-depth detailed tractor inspection, I'll throw up a link up here where you guys can check that out. Also, I'm going to throw a link on for the 9460R video that I did a fuel dosing pump on if you want more information on how to actually swap that pump out. I did it in that video. We got the inspection done, and we got a little bit of work to do, but it's not bad. So I found we got the fan drive that we got to replace. Yeah, we're going to replace the VGT turbo on this thing. Been fighting codes for the vane position mismatch, and I already put a actuator and a position sensor on it earlier this spring, but it's continuing to act up, so the vanes inside of that turbo are going to be acting up. If you guys want to see a turbo replacement, I just did one on an 8260R, which is going to be literally the same procedure as this tractor is going to be. So, but if you want to see the turbo on this tractor, let me know in the comments below. So we're going to do the turbo. Got a transmission output shaft seal leaking pretty good, and we're going to have to drain all the hydraulics down to get that drive shaft out, because oil actually goes through that drive shaft from the axle into the transmission. So you got to get that drive shaft off in order to take the hub off and replace that seal on the back. What else we got on this rig? Got to clean the transmission vent. It's clogged and dirty. That needs to be able to breathe in order to circulate oil between the transmission and the axle. So we're going to do that, and we'll go through and see what hours the hub oil, the hydraulic oil, you know, all that stuff's been replaced, so we know, you know, what service items we need to do on this tractor. But that's going to wrap it up on this tractor, and do a little update of what I've been up to. I know I missed last week. I didn't have any content to show you guys just because I was doing a bunch of work that you've already seen me do 100 times before. So mainly just doing fan drives and combine inspections, and you know, I just doing a whole bunch of work that I've already done content on before. So that's why I didn't have any content last week. But I've got 3 combines inspected so far, so we're gonna have quite a bit of combine work to come here in the future. So we're actually going to leave this place here today, and I'll show you the 2 combines that I inspected on the farm. We're going to get those combines hauled back to the shop due to the amount of work that we got to do to them. Plus I have to pull the engine out of one of the combines. It's a S780, so we're going to have to pull that back to the shop so we can pull the engine out of it, and I'll show you guys those combines here in a little bit. Alright, so we made her back to the shop. We didn't have enough time to go show you guys those combines that we're going to be hauling back to the shop and doing a bunch of repairs on. But there's going to be a lot of combine content coming your way, so stay tuned for that. Let me know what you guys want to see, and we'll go from there. But until next time, keep that green iron moving, and I'll see you on the next one.